Okay, in this video we're going to talk about how to create a sprinkler plan and riser diagram. First, we're going to discuss the symbols used for the various sprinkler components that are used on the sprinkler plans and riser, such as the symbols used for the piping and the sprinkler heads. Then we'll go through an example floor plan and lay out the sprinkler systems for that floor plan. And I'm going to take you through an entire example of how to lay out the heads and then the piping, and then move on to the sizing as well as all the other things such as the riser diagram. So we're going to start how to determine whether the building needs a sprinkler system, because that's the first step of designing a sprinkler system, which is to know whether or not a building needs one or not by code. Then we'll determine which codes to follow for that particular building. Then we will go ahead and lay out the sprinkler heads, okay, based on all the spacing requirements as well as any obstruction requirements that may need to be followed. Then we'll go on to laying out the pipes to connect all these heads that were laid out. Then we need to size the pipe and then move on to the riser diagram, as well as all the other parts of a sprinkler set that would be required, such as details, specifications, and other things that I'll cover later in this video. All right, so each sprinkler set has a symbol list, and every company might have a different type of symbol list, but generally they're very similar. And if you look down here, the concealed pendant sprinkler is usually a circle that is hatched with a solid color. The upright head symbol that we use is a hollow circle for the new upright sprinkler. A dry pendant sprinkler, we represent it with this symbol here. And a dry sprinkler is like this, right? So you have the sprinkler head, which may be in an area such as an outdoor area, or it could be another area such as a walk-in freezer, that if there was water in the system would freeze and potentially burst the pipe. So in those cases where freezing could be a concern, we use a dry sprinkler such as this here. And when the sprinkler activates, this section here is not filled with water, and this part here would be connected to the wet pipe system. So when the sprinkler activates, it releases some sort of valve inside, which then allows water into this piece right here, which would then discharge out through the sprinkler head. So this dry pipe head would be used in areas where freezing can be a concern. And we have some other symbols here. So the existing would be represented by the same symbol as a new upright sprinkler head, but the difference is instead of the letter N for new, we use the letter E for existing, and we make the symbol color yellow because the plot styles that we use, the color yellow, would print out a little bit lighter than the magenta color for all the new symbols. So we also have a symbol for an existing head that has been relocated. And by code, once we touch a sprinkler head, we have to replace it with a new head. So it's not an actual relocation of the same sprinkler head, but it's a relocation of the sprinkler location, and then that new location would be with a new sprinkler head. But we represent it as a R, which stands for relocated, but it's actually a new head that goes into that relocated position. And here is a complete list of the sprinkler symbol list. So we have existing pipe, which is on the sprinkler existing pipe layer, and the color is set by layer, and it's yellow, since this will print out a little bit lighter than the new piping. So all the magenta color using the plot style that we use comes out much darker and thicker in color, so that the new stuff will stand out from the existing. We have a demo line type, which looks like this. And all of these symbols are blocks. So they're all on the correct layer, which is the sprinkler new layer. This is on the sprinkler demo pipe layer. And each one of these are blocks, as you can tell. So if you double click this, you'll see that it's a block called new upright. And we have, so all these sprinkler heads are blocks. So if you double click this, it'll say new sidewall. And the reason for that is once the sprinkler plan is designed, we have to provide a table with the sprinkler count. So rather than counting it manually, it's better to count it using AutoCAD by basically selecting the entire floor plan and then typing in the command bcount right here and typing enter. And if you stretch this out, it basically counts all the blocks. So it'll be easy to figure out the count of each type of sprinkler head if we use blocks for these sprinklers. So that's the reason why it should be kept as a block. So that's the reason why all the sprinkler heads should be kept as a block. All right, so we're gonna go over an example now. Okay, and the example is gonna have these conditions here. It's gonna have a cellar, basement, 1, 2, and 3 floors. The cellar is a common area, so all the unit owners can go to the cellar and use it for storage or whatever else they need to. The building is 3-family, so the first unit occupies the basement and first floor level. The second unit occupies the entire second floor, and the third unit occupies the entire third floor. So the first step is we need to determine whether this building needs a sprinkler system. So the first step is we need to determine what type of occupancy group this is. So we go to the New York City Building Code, Chapter 3, which defines the occupancies. And you would have to find a similar section for your local codes for your project. And looking here, the occupancy for residential is a group R, which is right here, section BC 310. And you can basically just do a Control F to find a group R quicker. And if you look down here, you will see that for a R2, it includes occupancies shall include buildings or portions thereof containing sleeping units or more than 2 dwelling units that are occupied for permanent resident purposes. And if you look down here, R3 is occupancies shall include buildings or portions thereof containing no more than 2 dwelling units. Since we have 3 dwelling units, it would fall under the residential group R occupancy type. So now that we know what's the occupancy type, we can go back to this chapter 9 and find the rules for the group R. So here it is. So group R, an automatic sprinkler system shall be installed in group R fire areas. An automatic sprinkler system shall be installed throughout buildings with a main use or dominant occupancy of group R, except an automatic sprinkler system shall not be required in detached 1 and 2 family dwellings and multiple single family dwellings, townhouses, provided that such structures are not more than 3 stories above grade plane in height and have separate means of egress. So in this case, we have a 3-family unit, so it would not fall under the exception here. So we would need a sprinkler system. So now that we know that our example requires a sprinkler system, we have to now determine which codes to follow. So this is a recap summary of the different type codes. So we have the NFPA 13, the 13D, and the 13R. So the 13 are the requirements for sprinklers for all building types. 13D are for 1 and 2 family dwellings and manufactured homes, and 13R are for residential occupancies up to and including 4 stories, which this is revised to 6 stories in the New York City Building Code, Appendix Q. So the 3-family unit would fall under C, NFPA 13R, since it's not a 1 and 2 family here. And even though we can use NFPA 13, the 13R would be a less strict code that is allowed for residential units. So we will use the NFPA 13R for this example. So now that we know that we have to follow NFPA 13R, we would have to read the code to figure out where all the sprinklers are required under that code. So we have to add sprinkler heads in all areas required by code for the particular project we're working on. In general, a good design consideration is to keep sprinklers aligned with lights and centered in rooms as much as possible, and this is basically for aesthetic reasons. Another design consideration is the sprinkler count should be kept as low as possible while maintaining proper coverage. So if the max coverage is 12 by 12, which is a standard for residential heads, then you want to space it as much as possible. So 12 by 12 if you can, or a little bit less based on the layout of the room. This is to minimize the head count, which would reduce the construction cost of the sprinkler system. This here is a typical spec sheet for a residential head, and I randomly chose this Viking VK467 model, which is a residential upright sprinkler head. If you look at this column here, this gives you the maximum coverage area in feet or meters. We're going to use feet since we are in the United States. And the lowest one is the standard 12 by 12 feet throw, which is represented here in this picture down here. And this is the sprinkler head. So it's centered in a box that's 12 by 12. And the blue circle represents the water throw from that sprinkler head. As you read across the table on the right, you'll see the flow in GPM is 14 at a pressure of 8.16 psi. So if you look down this column here, if you needed to get a larger throw, let's say 16 by 16, we would basically use a pressure, or basically design the system so the pressure is at a minimum of 10.66 psi at the sprinkler head in order to get that 16 by 16 throw. And this column is for the ordinary temperature, and this column is for intermediate temperature sprinkler heads. So when laying out the sprinkler heads on the plans, you would create these rectangles based on the throw of that sprinkler head in order to help lay out the heads in a way so that you are getting the proper coverage. Now we'll talk about some design considerations when laying out the sprinkler piping. So you want to lay out piping to minimize the pipe length, again to make the installation easier and to keep the construction cost lower. Also, you want to determine the piping layout to minimize work to ceilings and walls. So if you look at these pictures here, if, for example, we look at this one here, this is during construction where, let's say it's a full renovation where all the ceilings will be removed and replaced with new. Then we're going to have these exposed joists if the building has a system of these type of joists. Then we could run the piping in between the joists easily without having to remove the ceiling if the ceilings don't have to be removed. And also you can have a ceiling such as this where it's going to be framed and you have space to run the piping below the slab. If the construction job is an open ceiling construction like this, where you can have the piping exposed, you could just run it as shown in this picture. And as you are laying out the sprinkler piping between joists, you want to avoid lights because some of these lights, they extend up into the ceiling by several inches. So you have to make sure that you also account for that when running the sprinkler piping to make sure that there's no conflicts between the piping and these light fixtures. Let's say you have a job where you are working on the sprinkler system and they don't want to touch the ceiling for whatever reason. It might be a decorative ceiling, or they just don't want too much disturbance in the building. Then what you could do is run the sprinkler exposed so you don't have to touch the ceiling, and then you can box it out with this soffit like so. This way you can minimize any ceiling work if that is required for that particular project. Okay, now we're going to talk about fire department connections. So in the NFPA 13R, the fire department connection code is in section 611.1. And the fire department connection are these things here, where the fire department truck will connect a hose to a fire hydrant, which contains the water supply, city water supply, and it's going to pump it through a pump in the truck, and then it'll connect to this fire department connection, which pressurizes the sprinkler system within the building. The location of the fire department connection has to be 18 to 48 inches above grade. So basically from this point to this point here has to be 18 to 48 inches. And this minimum 18-inch distance is so that the fire department connection remains visible in case there is snow, garbage, plants, or some other type of obstruction. And the 48 inches is a max so that it's easy to reach. And I believe those are the reasons for that distance range. So this code in the NFPA 13R is modified in the New York City Building Code Appendix Q. So if you read the NFPA 13R code, it's at least one fire department connection shall be provided for buildings accessible by a fire department that exceed 2,000 square feet or are more than a single story. Now the Appendix Q modifies that to basically delete this section and replace with the following: fire department connection except in buildings classified in occupancy group R1. So R1 are buildings such as hotels where it's a transient occupancy. At least one 3-inch single inlet fire department connection. Single inlet being this type rather than this type here where there's two of them. Shall be provided and located in accordance with New York City Building Code. Buildings classified in occupancy group R1 shall be provided with two-way fire department connections like this one here, in accordance with the reference standard NFPA 13/2016 as modified for New York City by basically Appendix Q. A fire department connection is not required in 1 and 2 family dwellings. This example is a 3-family dwelling, so we would need the single inlet fire department connection. I want to now talk about the sprinkler service entry point. So it's basically where the city water main has a pipe connected to it, which extends into the building, and then this point would be basically the service for the sprinkler system. And the service layout type for NFPA 13R can be a combination type service where there is one service pipe into the building, and the split to domestic system and sprinkler system occurs inside the building. So you can either have a separate service that comes in for the sprinkler, such as in this case here, where you have the city water main, which is in the street, and then it comes in, and this would be for the sprinkler, and you would have a separate service, which is basically a pipe that comes into the building and serves the domestic water system. So for NFPA 13R, we're allowed to use these combination type services. And there's two basic types of combination service. The first one, which we'll go over here, you have one service line coming in, one combination service line that comes in, and then you have a main control valve, and then from there it'll split between the domestic and the sprinkler system. So in this case is a little bit different from this case here. So for this one, the combination service comes in and then it goes into the water meter. And then on this side, it'll split to the domestic and then the sprinkler side. This city gate valve is at the sidewalk level. And it's basically, in other words, there's another name for that, which is a curb valve, C-U-R-B valve. And it basically looks like this on the sidewalk. It's got a cover that basically you can remove, and then you can use a tool to basically turn the valve, which extends down like so, down the ground to the valve that's on the water service. So in that way you can close and open the valve from the sidewalk level. So if you have this type of combination service, which makes the tap upstream of the water meter rather than downstream of the water meter, just as in this case here, where the connection point is downstream of the meter, you would have to use a double check valve. So in the NFPA 13 code, it states a check valve, but you can have two types, a single check valve or a double check valve. So for the sprinkler system in New York City, you would have to install a double check valve called a DC DA, which is a double check valve on the sprinkler service. If you have this type of figure here, where the branch off occurs downstream of the water meter, you could install a single check valve as long as it meets some other requirements in the New York City Building Code, Appendix Q. The water flow detector you see in this is basically a switch that is inside the pipe, and once it senses water flow, the switch is going to be triggered, which will then close contacts that can either be connected to a fire alarm system to alert people that the sprinkler system has been activated. If you don't have a fire alarm system, these water flow detectors can actually be wired to an exterior bell that will ring, and there'll be a sign next to the bell that tells people that once they hear the bell, the fire department can be notified. So we're going to talk about the test tee, and that is to be installed preferably at the end of the sprinkler run. So this is the sprinkler system, and this would preferably be at the end of the sprinkler run, and you connect it to a test valve, and then this will be the test outlet right here, which is equivalent to one sprinkler. So the resistance is equivalent to one sprinkler. So you want to keep the piping upstream of the valve in a warm area so that the water that's in it will not freeze. All the water in here would drain out by gravity to the outdoors. The reason why you want to install this test tee at the end, generally towards the end of the sprinkler system, in this riser, it's on the fourth floor, which is not the top floor, but close to it. At the roof level, it seems to be some sort of bulkhead. So you do have sprinklers here, but the test tee in this case is located at a higher level of the building. And that's basically to fill up the system. So once the system is installed, they would open up all the valves to allow the street water to come in and fill up the system. If it's completely closed off, the air wouldn't allow the water to fill up the system. So you have a test tee here that would be opened up, and that would allow the water to fill up all the way up to the test tee. So now you have more sprinklers that are closer to a water source, which means that if there is a fire, the water would discharge sooner out of that sprinkler head which would help extinguish the fire sooner. I'm going to now go over the example in CAD, lay out the sprinkler heads, the piping, and go through an entire sprinkler design from start to finish. So let's begin. So here's a floor plan of our example. We have the cellar floor, and we need the RCP plan because whenever you design a sprinkler system, you should always have the RCP plan rather than the floor plan, because we need to coordinate the sprinkler heads with the light fixtures as well as anything else that may be on the ceiling, such as speakers or security cameras and things like that. So here's the cellar, and we're going to use the typical 1/4 inch scale. This is the basement, and we have the first, second, third floor, and the roof level here. The third floor, the full floor, is occupied by one tenant. Also, the second floor is occupied by another tenant, and the first and basement is occupied by another tenant. So we have 3 units in this building, and the cellar is a common area. And the storage for the 3 tenants are in the cellar. So storage 1, 2, and 3. So the first step is to lay out the sprinkler heads. And to do that, we're gonna have to consider what type of ceiling is gonna be on each floor. So in the cellar, in this example, is not a finished ceiling. So we don't have any sheetrock ceiling. It's all gonna be exposed. So in that case, we can use upright heads. So typically we use upright heads in an area that is not finished, where the appearance is not that important. And for the upper floors like this, where the ceiling is finished, we're going to try to give it a cleaner look by providing concealed sprinkler heads. So we're going to start laying out the upright head. So we have to go to the symbol list and find a new upright head, which is here, and copy this. So you have to make sure that it's a block format, which it is. As you can tell here, it's a block called new upright, and we're gonna have to make a rectangle that is 12 by 12. So I'm gonna type in. So you could just type in the command REC, click a point, click D for dimension, and then type in 12 feet by 12 feet, and that will give you the coverage area, and center it to the sprinkler head. So now we're going to move this as one piece and try to line it up with the light fixture. So if the light is here, we'll put one, maybe not here, so we could get more of the coverage. So let's say we put one here, and we put another one on this side. So this would cover this whole area here. If we had one sprinkler head, we wouldn't be able to get the coverage for the whole space, right? Because the distance here to here is more than 12. So in that case, we would need 2 heads. And you want to keep some sort of alignment with the lights, which we did, and also some sort of symmetry. Okay, so now we're going to lay it out for all the other spaces. So in this tech room here, we just need one sprinkler head. So I'll place it on this side. I mean, it could go either here, here, or here on any of those sides of the light, but I'll just pick this one. Same with this. Same with here and here.